Okay, these are the notes that are going to accompany page 17 in your chapter 8 note packet. So make sure you take notes along with me, and then if I start going too fast, you can always pause. Or if you want to try something while I'm doing the problem, go ahead and pause me and then do your work and see if you can get the same answer that I do. All right, so now we're on page 17, so we're going to talk about decay and depreciation. So instead of a value going up, we're talking about that value going down. All right, so here's a real life context problem, and unfortunately, this is pretty accurate. Whenever you purchase a new car, depending on the car itself, there's a depreciation rate. Like as soon as your tires leave the parking lot of the dealership or the person's house or wherever it is that you're getting it from, so it starts losing value. Not all cars, okay? Just so you know, this is the majority of cars. So we've got a purchase value here of $25,000. All right, so that means that this is the purchase price for $25,000. All right, that means that this value is A. This is what you're starting out with. Okay. Then we want to see actually that the value of the car seems to be going down. So depreciating means that the value is going to be lower than 100%. So that means that this decimal had better be less than 1. So somewhere between 0 and 1. All right. How much is it depreciating by? It's at a rate of 8% a year. Remember, a year is annual percentage rate, so that's APR. So that's APR. All right. How much will the car be worth in 10 years? All right, so that's going to be our time frame here. So 10 years, that's going to be T. Now what's nice about this is that the time frame in years already matches the depreciation rate, which is also in years. So that's nice. So I don't have to worry about changing the percent itself, kind of like we did previously, like monthly or quarterly. All right, so let's go ahead and figure out this rate. So we know that we are going to start out with 100% of the value, but then we're going to be losing 8% per year. So we're going to be going down in value. So if I do 100 minus 8, I'm going to get 92%. Well, don't forget, we got to pick up the decimal and slide it twice to the left. If you can't see the decimal point, it's actually hiding right behind the last number. So it's right there if we can't see it. All right, so if I grab that, I believe that's going to give me 0.92. All right. In my equation, that's going to be B. That's my multiplier. Notice that it is lower than 1, like I said, which makes sense. We talked about this in class. If the multiplier is less than 1, so somewhere between 0 and 1, we talked about it can't be 0, can't be 1, can't be negative. If it's somewhere between 0 and 1, then that means that your initial value, your 0th term, your starting point, your y-intercept, however you want to look at it, is going to be decreasing over time, so it's going down. All right, I think we're ready now to go ahead and build this equation. All right, so I've got T of n using my equation, a b to the n. Let's plug everything in, and then we'll plug in the time frame in just a minute. So our a is 25,000. Our b that we just found is 0.92. And then n, so the exponent represents like how many times, so how many years is this going to be going through? All right, so it's 10 years. All right, so we want to do 10 here. So I'll do T of 10 years. It's going to be 25,000 and 0.92 to the 10th power. Now remember, if this is starting at 25,000 and it is decreasing in value, then that means we expect this number to be less than 25,000. So if we type this into the calculator, go ahead and write out all of my decimals, or at least all the ones that the calculator is showing me. It's unfortunate, but it's true. After 10 years, the car's only worth close to $11,000. All right, so if we're trying to trade this in, or if we're trying to get value for it, chances are they're just going to chop it right off for us. Now, I'm sure you guys know this, or maybe you don't. When people go to sell something, so like they say try to sell this car, there might be wear and tear on it as well. So let's say this person took like immaculate care of their car. They might be able to sell it for more than this. But again, that's their choice. They could try to see if there's anybody out there that's willing to pay that much money for it. Now, if the wear and tear on it is they didn't take great care of it, maybe they've got some alignment issues or whatever is done to the car, this value can go down. So this is kind of like the starting point for people when they're selling their cars. All right, assuming it looks brand new, assuming it's been taken care of, assuming there's like no crazy wear and tear on it, they're going to be able to hopefully sell it for this much money. And it also depends on the market. So if people are in the market of trying to buy a car, buy this specific car, then they might actually pay more than that. Chances are you're going to end up selling it for less than that, though. Okay, let's go to the next page. All right, so here we have, rebound ratio. This takes us back to first semester. So we want to test the rebound capabilities. Okay, from a drop height. All right. Drop the ball from a height of 250. Okay, that means that this point, so in the beginning, it was at a height of 250. All right, then let's see what happens next. The first bounce, okay, so this is it coming back. The first bounce will be 210. Okay, so the first bounce, so I can write this as 1 comma 210. All right, so we have 2 points here. I think one of the ways that we set this up originally was to set up a table for ourselves. So if we want to figure out the rebound ratio, so we're on part A, I go ahead and set up a table here. I would do 0, 250, and then 1, 210. And then we actually talked about this a couple of ways in class, but one of the ways to do it, and it is a rebound ratio. Ratio implies there's some sort of multiplication happening. We know that 250 times something, I'm going to call it R, gives me 210. So you can actually write a little equation for that. So 250 times R is equal to 210, and this should look familiar. This is stuff that we did before. Divide by 250 on both sides. The 250s cancel. And then I'm going to go ahead and type this into my calculator. That gives me 0.84, which makes sense because if you drop the ball from a height of 250, if the ball doesn't bounce all the way back to you, then that means that it lost some of its height. So if we think about the depreciation problem on the previous page, or on the previous question, the value went down. So the $25,000 car went down to close to $11,000, and the B value, so the thing that we were multiplying by, was less than 1. Same idea here. We drop it from 250, it only comes back to 210. It has lost some of its height, which means the number we're multiplying by should be less than 1. So if I have to build an equation out of this thing, this is going to be the B in my equation. This is my multiplier. Oh, forgot my I. All right. Predict the height of the bounce if you dropped the ball from 25 feet. All right. I'm going to actually set up my equation here. So I could do this a couple of different ways. I could continue my table. So one way is to continue the table. Or write an equation. write the equation. So if you want to continue the table, you're welcome to. Now would be a perfect time to pause me. If you want to set up the equation, go ahead and do that. Now would be a perfect time to pause me, and then unpause when you're ready to check. Okay, so I went ahead and wrote an equation from this. So you'll notice that I made one tiny little change. I still used the 0.84 as my multiplier. However, it says that the drop height this time would be 25. If it's going to be 25, then this is telling me what my A value is. So that would be equal to A. Now it said, or the question was, predict the height of the bounce if you drop the ball. Okay, it doesn't say that I drop it multiple times. It just says that I'm going to drop it once. So if I drop it from 25, how high does it come back? So I set up my equation, drop height of 25. The rebound ratio, or the bounciness of the ball, is 0.84. So at this time, if I want to figure out what happens after one bounce, I'm going to plug in a 1. So then if I type this in, I get 21, which really is kind of what I expected, because if 250, so here's my little thoughts off to the side, if 250 turned into 210, I think I can kind of just ignore the zeros. Then I would expect 25 to turn into 21. That would be my expectation, and it worked. So these are just my little mental ramblings off to the side. Okay, part C, write an equation for the bounce heights of the ball after n bounces if it's dropped from initial height. Okay, the initial height's changing again. So initial height of 575. All right, so let's say if this is going to be 575, then that now is our A value. So A is 575. Okay, still the same ball though. So the bounciness ratio is still 0.84. So when it says to after n bounces, this is just the generic equation. So the one that I just wrote previously and the ones that we keep writing. So it's the T of n equation. So drop height is 575. The rebound ratio is still 0.84 and then n. So that's my generic equation. That's the answer to the first part of this. But then it says, how high will the ball be on the 12th bounce? Okay, the 12th bounce, this is telling me what n is going to be equal to. So this is telling me n is equal to 12. All right, now we can go over to our equation and let's type in a 12. Now I know for sure it's going to be smaller than 575. So if I take my 575, my 0.84, 12th power, make sure you type this into your calculator. I wouldn't expect you to do this by hand. Always type this in your calculator. All right, let's see. Yeah, 12 was approximately 70.96092653. Now this isn't a value of money, so it wouldn't make sense to necessarily truncate it at the second decimal place. However, you guys know I want you to be accurate to 3 decimals. So what you could do is you can round this if you want to, which is fine. So if you're going to round it, 9, 6, okay, you would look at the 9 to tell the 0 what to do, and it tells it to go up. Or you can truncate it. So if we truncated it, so I'm going to round it first so you guys can see, but if I truncate, all I do is chop off all of the numbers after the 0. Either of these is going to be fine. And then let's put some units on this thing. It did say centimeters. So I'm going to say centimeters. And since it was the word problem, I would say that at the 12th bounce, the ball would have a height, or would attain a height of, let's see, I'm going to go ahead and do the truncated version. So it's up to you guys, but I'm a big fan of not having to round if I don't really have to. Okay, and that should finish the notes for this page.